So one way to multiply vectors is called the dot product. If you have two vectors, we'll call it A1, comma B1, and A2, comma B2. Then the dot product, U dot V, is calculated by multiplying the x components together. A1 times A2. And you multiply the y components together, B1 times B2. And you add those two values together, so you get a single number as the answer to a dot product. So let's look at an example. Say U is 3, negative 2, and V is 4, 5. And the dot product, U dot V, will be x component times x component, 3 times 4, plus multiply the y components together, negative 2 times 5, so we got 12 minus 10, so the dot product is 2. With the dot product there are properties. The dot product is commutative, meaning you can flip the order. U dot V is the same as V dot U. Multiplying by a scalar, it doesn't matter when or where you multiply that scalar, it just gets multiplied in. It also works for distribution. If you have adding two vectors and then dot product, you can distribute and do the dot product. Basically, the one that's being multiplied with the dot product can be distributed to the other two. And also, if you take the length of a vector squared, that's the same thing as doing a dot product with itself. Now you might be wondering, what is the number that we get for the dot product? And it's related to cosine. It's related to the angle in between. Specifically, the dot product is when you take the length of each of the two vectors involved times the cosine of the angle in between them. So we can use that to find the angle between two vectors. So let's find the angle between U and V. And U is the vector 2, 5. And V is the vector 4, negative 3. So to find the angle in between, we're trying to find theta. So we can calculate the dot product. We can also find the length of each thing. So let's first find the dot product. Two times 4 is 8. 5 times -3 is -15. So our dot product is -7. Then the length of each. The length of u square root of 2 squared plus 5 squared and the length of v is square root of 4 squared plus 3 squared. So if we were trying to solve this, we'd plug in all those numbers, but then really we would divide by the lengths on each side. So you can rewrite it as cosine of the angle in between the vectors is the dot product divided by their lengths. So the dot product is -7 divided by their lengths, 5 times the square root of 29. So that's what the cosine of the angle would be. And by doing inverse cosine or arc cosine, would get that the angle arc cosine of -7 over 5 squared to 29, we get the angle's about 105.1 degrees. So if we expand this a little bit, if the dot product were 0, we'd be taking arc cosine of 0, which would give us, as long as the vectors aren't of 0 length, which they can't be, we would get arc cosine of 0, which tells us a 90-degree angle. So that tells us that if the dot product is 0, that means that the vectors are perpendicular. Another term for perpendicular is orthogonal. You might see that written in some places. So another thing we can talk about with vectors is the component of one vector along another. So if you have two vectors, like this, we have vector u and v. If we want the component of vector u along the vector v, really what that's saying is in the direction of v, how far does u go? Just like when we talked about the x component and y component, we're talking about how far it goes in the x and y directions. Now we can do that for any direction. So it's component of u in the direction of v is really what that's saying. So what that means is how far would that go along vector v. So it's perpendicular. I kind of like to think of it as the shadow, like how long is the shadow if you were to shine a light? How long would the shadow of u be onto v? So the component of u along v is just this length right here. And you can find that if you know the angle, which we know how to find using the dot product. And then we're looking at, this would be a right triangle formed with this dotted line that I drew. So we're looking at the adjacent side where u would be the hypotenuse, so we'd be using cosine. And that would equal adjacent over hypotenuse, so that would equal the component of u along v divided by the length of u. So simply rearranging that a little bit to calculate the component, multiply by the length, and we have the component of u along v is the length of u times cosine of the angle in between. And we know the angle in between is related to the dot product. U dot v divided by their lengths is how you can find cosine. So if you substitute that in, we'd have the length of u divided by the length of u. Those are going to cancel. So we get the dot product, u dot v divided by the length of v. That is the component of u along v. The component of u onto v. And remember, the component of u onto v just tells us how long would u be in the direction of v. How long is u in the direction of v? But remember, that's just the magnitude. If we wanted to create a vector about that, we would still need the direction of v, because vectors have magnitude and direction. So if we take the component and we want to give it the direction of v as well, we would have to multiply. We have the magnitude, so we need the direction from v. To get the direction from v without the magnitude, you just take the vector v and divide by its magnitude to get rid of its magnitude. That leaves us just the direction of v. So what I mean is that's a vector in the direction of v that doesn't it has a unit length. It's got a length of 1. So if you take the component of u along v with the direction of v, you put those together, you get the projection. Of u onto v. So now it has that length of the component, but also the direction of v. So you're taking this here, but you're making it a vector. That's the projection. So to get that, you're taking the length from the component, so you're taking u dot v divided by the length of v. And then you want the direction of v, so you have to multiply it by vector v divided by its length. So you get the unit vector. and that's the projection of u onto v. You can simplify that a little bit and make this be the length squared. So we got the projection of u onto v would be the dot product of u dot v divided by the length of v squared times vector v. So there's some important formulas: the projection of u onto v and the component of u onto v. So if you are given two vectors, say vector u is the vector 1, 4, and v is -2, 1. We can find the projection of u onto v. So that would be the component, which is u dot v divided by v. So u dot v divided by the length of v that would be the component. Then square the length of v and multiply it by the vector v to get the projection. So u dot v, let's calculate that first. 1 times -2, 4 times 1. So the dot product gets us 2. And the length of v is the square root of 2 squared plus 1 squared. And if we square that, we just get 5. And then multiply by the vector. So first, let's put this all together. 2 over 5 times vector v, which is -2, 1. So you just distribute that. It's just a number. You distribute it to each component. So our projection is -4 over 5, comma 2 over 5.